Hi, this is Tom Cherryholmes with the next video in the Amiga PAC-MAN development series. In the previous video, we started talking about tasks. Tasks are lightweight processes that the Amiga exec provides so that you can do multiple things at the same time within your program. In the previous video, we went over a standalone task which we called the PowerPelletTask. Its sole purpose is to change the color palette every fraction of a second to take and make the power pellets blink. In this video here, we actually take and extend the power pellet task, make a new test harness here that adds that, but also adds a score task. This score task's responsibility is to maintain the scores that are displayed on screen. The unique thing about these particular score task is that it has a MessagePort, and this MessagePort accepts messages, which basically revolve around setting the score, adding points to the score, and stopping the task whenever we need to stop it, such as when the program exits. So let's go ahead and start building this goofy thing. As before, we go into our workspace, and I will go in and pull from PowerPelletTask, and we will duplicate it here. Wait for the duplication to finish. I would like to dig into the operating system source code at some point to see why it takes so long to take and duplicate these drawers sometimes. But, you know, we'll just move on with it. This is how it worked in the early versions of Workbench. We'll know that it's done whenever the icon changes back to the pointer. Then we'll just take and move it out. Okay, and we'll go ahead and just, once it's finished copying, we will rename it. And we're going to call this, quite literally, the score task. Or more specifically, the ScoreTask test harness here. We'll do the usual shuffle that we've done before, renaming the files, renaming the source code, and the resulting executable. Making the appropriate changes to the make file, using Emacs, and now we're ready to go. At this point, we can open up ScoreTask, and we can start modifying PowerPelletTask for our purposes here. And this becomes we'll make our little description here. Demonstrate message passing, sure, why not? And let me go ahead and pull my notes up here so we can actually start doing things as we need to here. We shouldn't need to add any additional things into include, but we will need to make sure that we have, in addition to our create tasks, that we have find port, because we're going to need it to take and find the public message port that we create to send our commands to. And do we actually need? We'll see. Oh yeah, we do, because we're going to, okay. We already have it here. And of course, because we're using the timer here, we have create extio. Okay, that's great here too. So, okay, we have our additional functions that we need to add. And now we can come down here to the bottom of our data structures. We'll keep BM pellet here just because we're going to use it. All of this is still here. This is fine. But we're going to add a new structure type. We're going to have in our score task, we need a way to send something messages to our score type, our score task. We're going to be doing that across message ports. But we need to define what message we're going to send across to our message ports here. And like everything else, if you actually take and dig into the exec manual, you will see plenty of examples showing how to take and create new message types. And the common pattern that you will see over and over again is that you take an existing structure at the beginning of your new structure here and you extend over the top of it. The first new entry that we need is what command are we going to send? It's just going to be a number corresponding to the command that we're going to send. The second is going to be quite literally the player number that we're going to respond to here. So we have our message command, our player number, which is either 0 for high score, 1 for player 1, 2 for player 2. And we have, as part of our message, a pointer to a new string with which to take and handle our score. Our score is represented as a string of ASCII digits in a character array, and that includes adding numbers to the score here. And ironically, that makes this it's very fast and straightforward here. We don't have to do any crazy divisions or anything else. It's just a simple add with carry. That's why I'm doing it like this. So, the score data. Okay, great. So we have that, and it would be prudent in the sense of code readability to define some constants for our different score commands. The first one here is score command reset, and its whole purpose is to take and do the initial playfield drawing here, but also to take and reset the score values all back to 0. We also have score command set, which basically says, I want to set the score to an explicit value, say start at 100 points, whatever. We also have score command add, which adds a point value to an existing score, doing all the additions and carries needed to take and ripple it across the text string. We also have a command here that's rather special, and this is the stop command, whose whole purpose is to put the task in a wait loop so that it can safely be deleted after the fact. We take and in stop, we take and clear everything out, close all our ports, make sure, empty our ports, close their ports, make sure everything's nice and clean, and then enter a wait loop to be waited to be deleted by the delete task. So, with that, okay, so now we have those two bits and pieces ready to go. Now, we need to actually implement our basic task here. And we'll call that ScoreTask. This is pretty much like everything else. We have just a standard function here. We're not going to return anything, so of course it's void. And it's just going to essentially be a switch loop of sorts. We know that because we want to communicate with this particular score task, that it needs a message port, and that we need pointer to the current. This is a pointer to the current score, because this is going to change. This pointer here is going to change depending on the command that we want to send to point to one of these other character arrays here. We also need some additional X and Y screen coordinate variables here that we're going to take and put here. And X needs to start off with score X. What is score X? Well, those are defined quite literally as a set of screen coordinates. We'll go ahead and put them up here for the sake of readability. So we'll go ahead and define text height as 8. We'll use it later. That's the height of our font. Header height score X, which is starts at 200 at X position 232. 24. Score high score Y position, which is score high score Y, header 1 up Y, which is 48. And I'm going to kick myself here because I didn't show what the program was going to be beforehand. But if you saw my previews, video previews before, you saw what I'm actually going to be creating here. I apologize for that. I will remember next time to show the program before I actually make it again. But we're basically just defining a set of constants here for the sake of code readability that point to coordinates positions on a 320 by 200 screen. Score 1 up, header 2 up Y, 72. Again. And you'll notice that I'm defining some of these relative to constants that are already defined here, so that if I change the positions of the headers, the scores will take and move down with it. It makes this all easier to deal with. So finally, score X is for all of these, all start in the same, all at the same X position, which is 264. So we'll come back down here now. Back down here to score X. So now you know what score X is actually going to be. Give me just a moment to pull back where I was. Now, we need to, because we're creating a new message port. If you read in the exec manual for creating message ports, it tells you very strongly that you need to turn off multitasking for just a moment so that you can create your message port. What do we need to do to create our message port? Well, that's pretty simple. We just take our task port that we've defined above here and we pass it into create port. And since this is a public port, now, instead of giving it a 0 or a null, we give it a name. And the name can be whatever you wish it to be, but I'm using some common conventions that I've seen in other programs here to take and differentiate scores, tasks, and ports and whatnot. So score.port is what we're calling our message port that we're going to be talking to. And again, if we don't deal with it, if something happens, then we just need to make sure to turn our multitasking back on and bail. Oops. You know. Otherwise, we permit. Now, at this point, our message port is created. And we can basically sit and spin on our wheels forever doing the following. This task is going to now sit inside here for the most part until it's told to stop grabbing messages. The first thing we're going to go ahead and do is create a pointer to our score message type that we did above. That's going to be referred to as MSG, which is the current message that will be sent down the line. And all we're doing, we're going to say, this is part of the magic right here. And get our message. We're going to wait on our task port and wait for a message to arrive. This is a very important way in which exec works, and one of the reasons why it is so efficient. Because what will happen here, when you take and put a message into that message port, that message by default is designed to take and send a signal to our task, indicating into our message port here, into our task, indicating that there is a message waiting. So while this is happening, exec can then preempt immediately and wait on other tasks and deal with other tasks until a message comes in and we get a signal that there's a message that's come in. So we're not just sitting here spinning our wheels, constantly polling, waiting for a message to show up and burning CPU up in the process. So if there are messages, what will happen, it will sit here, this task will stay right here until something happens. Oh, now there are messages. And this is an important pattern right here when you're dealing with message processing. You'll see that I'm using a while loop here. And this while loop right here, again, the same pointer to a score message. This is basically here to keep the compiler happy. Get message. We are basically sitting in a loop doing a get message call. And as long as get message doesn't return 0, it will return 0 if there are no messages waiting. Otherwise, it basically returns, it returns a pointer to the message that it just got. So, with that, we will now be able to take and process our message. Okay? So while struct message, score message, get passed. And we want to do this as long as that there are messages in the queue, because multiple messages may have shown up comparatively at the same time by the time that this task has been preempted back into running state. So there may be more than one message going. So it's a good responsibility, it's a good pattern to basically take and just loop over these messages while they're in the queue. So while that's the case, we've got our message, and we can, we've defined our structure, and we've defined MSG as a pointer to a score message construct. We can switch over, we can create a switch here to deal with our different message types. Score command reset, score command set, score command add, and finally, Score command stop. Okay. For now, we will just take and put breaks in there. So now this, it's going to sit here, and ostensibly we take and break off into each one of these individual tasks that we want to deal with. Okay. Finally, with stop. Stop is a bit of a special one because we we break out of this loop as hard as we can. Score stop. And we immediately take and do this. Go to label, and then one of the things that we have to do, if we are told to stop at any given particular point, we need to drain the message port. This is our responsibility. As our task, because we created this port here, it is our responsibility to take and drain the queue of any messages that may, drain the port of any messages that may have been queued up for it. That's easy enough to do. We just flush it by repeated get messages. That's it. Once that's done, we can delete the message port. And we can delete ourselves. If you take and send a 0 to delete task, that is exactly the same as basically saying, okay, I want to delete myself. 0 is self. That's how it works. Okay, see how we're doing on runtime here? All right, not too bad. We'll just take and continue on. One moment while I put that window back up here, what I was doing. I apologize. I just wanted to see what my runtime was. So, now that that's in place, we've got the skeleton for our task. And we can go ahead, and I'll go ahead and just add the task for it here in main so that we can call it. And I'll put it right next to the create task for this guy too. Same thing. We'll take and set the priority of this down to 0 for now. And you'll notice that the parameters for our new task here are the same, in the same pattern as the same ones for our PowerPelletTask. Create task, the name of the task, the priority of the task, and the pointer to the function or the PC for that task. And finally, the amount of stack that we want to allocate for this right here. It works exactly the same way. We make sure we have task right here. We'll go ahead and add it here. Delete it if we need to. For whatever reason, maybe it bailed, maybe it failed, and maybe we need to leave. So if that's the case, then that's what we do. So there's struct task. I'll go ahead and add. Make sure that's the right thing. Okay, there we go. So now we have our task and it's set up. Well, how do we actually take and deal with, after we've created this task, how do we find the message port? Well, to do that, we actually need to use the find port external that we defined earlier. Let me come down, scroll down here so I can see what I'm doing. We create the task, okay, fine. And Then we take and we have our task port here. Task port, of course, let's see. Struct MessagePort task port. Okay? Remember, these are local variables, so I can do this just fine. Now at this point, the task is being created, and this task is asynchronous, so it may take a moment for the message port to actually show up. We're going to wait for it. We're not going to do any timing out here, so if this task doesn't get created for some reason here, then we might be in trouble. But this is a test harness, so we'll get away with that for now. So while we don't have a task port, while task port is null, which by the way, let me go ahead and make sure that task port is indeed null. We take and we try to find it. And that's really all we have to do. We say task port is equal find port score port. If it doesn't find it, it returns back a 0, which is null. So we're waiting for this to change to something that's non-null. So it will wait until the port actually exists. And then once we do that, we now have a pointer to that port, and we can now use it. Now, what about messages? This next part might sound a bit convoluted here, but it has to do with the fact that messages in exec, like everything else, are pretty much zero copy. Exec does the minimum required to take and move these things around, which in this case is literally just take and move a pointer to your message from one port to another. It makes the whole process very fast. But it does mean that you can't statically allocate messages, one message, and expect to consistently use it one right after the other, because the message might be traveling through the system doing something, and you'll get some very unexpected results. So we need to dynamically allocate our messages. Let's start with our reset message. Give me just a moment here. Again, coming back into main, we'll start building our individual messages. That's part of our main loop here. And we have struct ScoreMessage, and we'll have messages for reset message and set one message and set two message. Okay, we'll go ahead and get those running. And let me pause for just a moment here because I need to take and gather my thoughts. Okay, sorry about that. I needed to remember how I actually implemented add message here. So, okay. We have our main messages here. Add message will actually be implemented on the stack as part of the loop. But let's get to it. Let's actually send our first message, which will take and set up our score reset. For that, we need to, after we've come down here, made our message port, created our task, waited for our task for our port to show up. Now our port's here. Now we can send messages here. Let's go ahead and make one. So we define reset message. This is dynamically allocated. It's a score message, and what we will receive back is a pointer to that score message. Instead of malloc In Unix, you've got PAC-MAN here on the Amiga side of things. But it works in much the same way. The number of bytes to allocate, but here's the difference. We need to specify memory type. This is important again because the Amiga has different types of memory which can hold different types of information, certain things that can be accessed via the custom chips versus not. In our case, we really don't care. We just want some public memory, doesn't matter if it's chip or fast, and we want to go ahead and hopefully let, I can repeat, PAC-MAN clear it for us. I'm going to set it all to zeros. Okay. If fine, go to buy, that's okay, that's cool. Whatever. If we can't, then that's okay. Bam, bam. All right. Otherwise, we start filling in the reset message. The definition of message is literally defined in the exec manual. And it's all part of, anyway, it's in the exec manual. And there's a structure for it here. Yeah, I won't go into it here because my PDF viewer just stinks on ice for looking through this stuff. But it's in the exec manual. MSG. And remember that we had, as a part of our initial structure, we had a definition of the existing message type. And it carries with it a number of its own members, such as node types, which are the exec nodes that are defined as part of exec's list structures. We need to give this a type of node type of message indicating to exec that this is a message that we're going to send. We need to give it a length which corresponds to the size of our message. In this case, it's very convenient. We can just do this. Size of struct score message is sufficient. And we can then take and set our command, score command reset, and finally, all we have to do to make this message work okay, task port, here's our message. That's it. Bam. We have just crafted our first message that's going to get sent. Okay? So that's going to come over. And just for the sake of implementing it here, what we will actually do is we'll go ahead and just implement it. Just come back over here. Come back over to ScoreTask for a moment. And remember that we took and made these message types here. We'll come over here and implement a function called ScoreTask reset. Okay? Okay, boom, boom, boom. We'll come over here to ScoreTask reset real quick. Just look at my notes. And it actually is going to need a number of strings that we want to take and deal with. S0, S1, and S2. These correspond to the high score value, the player 1 value, and the player 2 value. So easy enough. Bam. And all we're going to do, we're going to go ahead and these will take and set. Each one of these scores, recall that they're 7 characters long. 1, 2, 3, 4, 5, 6, 7. Okay. Those get set, and we're going to take and do some graphics commands into our PAC-MAN window, into its raster port. And move into place and draw some text. That's it. That's all we're going to do. So you'll see all those defines that we did up here are now being put to use. So again, text, and this becomes S0. You'll notice that there are numbers here, and these just correspond to the length of the string that you have over here. Again, S0. And the header, again. 1, 2, 3, 4. Like that. You notice I'm making sure that each one of these is exactly 7 characters long. Okay. ScoreX. You'll notice that I'm using ScoreX a lot here. Score 1 up Y. Text again. S1 again. Here we go. ScoreX header 2 up Y. So text S1, same thing. 1, 2, 3, 4. Yeah. Just like that. And we're almost done with this part right here. Sorry, guys. Here we go. So you'll see in each case, it's the same pattern over and over again. The headers, then the score values. The headers, then the score values. The headers, then the score values. And that's the entirety of ScoreTask reset. But we also need to actually implement ScoreTask set here, so we might as well just go ahead and do this. This is a simple enough little function here. And its whole purpose, there's a source and a destination. And its whole purpose is to just do a quick little move here. This whole loop is unrolled, so D of 0 is equal to S of 0. Yes, this is silly, but it's also going to be pretty fast. That is the entirety of ScoreTask set right here. It takes and just copies the value in, and there we go. So we have that, we have that. I'm going to take, and this should be enough to get started. We'll go ahead and build this here to see how we're doing. Maybe I introduced some syntax errors. If so, we'll take and fix them, and then we'll just move forward. Happy little accidents. So now this is PDisk ScoreTask. Okay, here we are. We'll take and build it. Execute and make like we have before. And let this thing compile. We did a lot of work here, and maybe there are some typos. Let's go ahead and fix them when we see them. It's the day after Halloween, and, you know, Halloween in this neighborhood's pretty low-key. I mean, it's, and we have the neighbors nearby, and they come by with their kids and whatnot, and they come in a few small bursts, but everything is usually over in our neighborhood by about 9 o'clock at night. So, you know, pretty low-key. Ironically, my wife and my daughter go elsewhere. Okay, so we've got errors here, 160. We start at 160. Let's go ahead and start fixing them here and see what happened. Wait, oh, I'm in the wrong. I still have this open. Excuse me, sorry. Let me get rid of these. Excuse me, wrong. There we go. Let's open the right file here. You can tell the Amiga is a multitasking operating system. We've got a whole bunch of things going on. And yes, I'm doing things for videos after the fact. Oh, KNRC. Got to define their types, don't we? Let's fix that, shall we? This should at least fix that spill of stuff at the top. Let's see how we do. There's going to be other problems. I see another one here, so that's 186. So I'll go ahead and fix that one too while I'm thinking about it. R port. There's an R, yeah, so there we go. Another typo right there. All right, so we'll just go ahead and fix that one right here. Continue on. But yeah, so my wife and my daughter went to another neighborhood nearby that, you know, they have food trucks and all sorts of stuff, and her and her friend went as characters from the musical Heathers. So my daughter went as Heather McNamara, and her friend went as Heather Duke, and they looked absolutely fantastic. I mean, it was just, it's great. You know, they had such a great time. While I sat here and defended the fort with odd little skips. So I used the time to basically take and work on the next upcoming videos for this particular series. So I've made a whole bunch of preview videos. So there's stuff in my backlog, and basically these will get turned into full-blown videos soon enough. 241. Let's have a look. This will be stupid, but we'll get it. Oh dear God, don't do that. It's like, nope, backspaces don't work. Hello. So what happened here? Let's find out. 241. ScoreTask. Am I still here? ScoreTask 240. No reference. Okay, so no reference to data. That's fine. Okay, those are warnings. So invalid. Okay, 388, 389. So let's go in here. We'll deal with those in a second. Okay, 388 and 389. So reset message mn node ln type. So I just need to make sure that when I do these, that I've typed them correctly. Mn node ln type. So message mn node type. Node. Probably because I'm missing a couple of includes. Let's see if we can add them, which will add the required bits that we know that we need to have the structures. So we know we have memory, interrupts, We need types, we need nodes, we need lists, memory, interrupts, tasks, devices, timers. Okay, so what happened here? Give me just a moment. I will pause the video here while I see what's going on. Oop, found it. Okay, so this is not a pointer to an existing message. This is an extension of the message here. So it's not a pointer, but an actual inclusion of that message structure in here. Yes, that's important. Let's try that again. And that should fix that. That should fix that. So the rest of these are warnings, and that's perfectly fine. We should be okay now. So yeah, once I'm finished with this video here, I'm going to continue on and we'll start talking about what are called graphic elements and part of the animation system that is part of every Amiga and their Kickstart ROM. They're called gels, you know, kind of like pixels or picture elements. You had gels, which are graphic elements. And they are essentially the blitter objects and sprites, and they're composite objects called animation objects, which can be used to move complex things around on the screen pretty effectively, with or without collision detection, however you want to handle that. It's as abstracted, or as complicated, or as simple as you want it. And the next few of these particular videos are actually going to go into the process of exploring these graphical elements that have long been a part of the operating system but are understood by very few, and showing how to use them in the case of this to take and draw Pac-Man, the individual Pac-Man characters on screen as needed. Okay, so now we got this. Let's go ahead and run it. Okay, we has a bug here. Yeah, we have a big bug here, and it went crashy crash. Let me see if I can see what happened. It was inevitable. This was going to happen. Let's just see what I did wrong, and I will pause the video here while I take and do a little bit of exploratory searching here, because this is copied from working code, so I obviously copied something wrong. So let me by the way, this code is on GitHub, so if you want to take and look at this on GitHub, you can look at this on GitHub via a link in the description, and you can see this code for yourself in context and follow along. So let me go ahead and get set back up here, and I will unpause the video once I figure out what happened here, and I'll let you know what happened. I realized here that I didn't follow my own rules here. We need to, our warnings actually helped us here, so we need to actually take and all high score reset. So let's do that, and we might as well, since we have this here, actually implement ScoreTask set while we're at it. We got that, ScoreTask set. Let's come down here. There's ScoreTask set. So now, as part of ScoreTask set, we actually start to use the player number here. We call we add the message, the score to high score. Sorry, not add, but set. Sorry. Same thing here. We might as well. score1. We weren't pulling our parameters off the stack correctly, so shit was getting sideways. There we go. That's what we need for command set there. We just take and break. We'll go ahead and implement score add in the next pass here once we know this compiles and works as expected. So now we have ScoreTask set, ScoreTask reset here. We have the commands, and they are now being called as part of our messaging here. Okay. This is a case of I tried to cut too early. And it's my bad. Let's try this again and see how this works. The thing that surprised me a lot here is basically uncovering all this stuff that I knew at one point and remembering all the weird little all the weird little gotchas that happen, such as especially when taking and passing messages, making sure that you need to dynamically allocate them. Once you're done with a message, you can reuse it, but if you aren't replying to that message, if you aren't sending that message back through a reply port, which we'll cover in an upcoming video here, then you might not know when this actually happens. So, oops, let me make sure that this is correct. I'm sorry, it's probably not high score, it's high score. Oops. Let's fix that. Okay. Just typos, simple little typos. We're not using the score variables yet. We're not using the set1, set2 messages just yet. But we will take and define those. We will define those shortly. But I wanted to actually shake and show our reset message working as intended. That's fine. We'll see 420, that's fine as well. We're not there yet, but those will be used very shortly. Matter of fact, while that's happening here, we'll take and just do this here. Okay, just wanted to take a look ahead a little bit to make sure that I was covering all the bases so far. So far, so good. After we take and implement reset and show that reset is working as intended, we'll take and create our set messages, which will set the initial scores for player 1 and player 2. And a rather interesting peculiarity of PAC-MAN, like a lot of early Namco games at the time, the score is defined as 2 zeros that are right justified. Which is another reason why I implemented the score like this. So, run. Hopefully this is okay. We have our blink. Well, at least we have our blinky. Let me see what could be happening here. This will stop in just a moment. It's okay. Come on. Maybe, maybe not. Possibly not. Let me pause and see. We'll do some digging here and we will come back. I apologize for the for the cuts in this one here. This one just had some unexpected turns, which hopefully I'll take and work out here. Excuse me. Well, at least now I know that my score task got held here. The other tasks are running. That's the irony here. So if I come back down, you'll see that our PowerPelletTask is still running at full bore here. If we take and cancel, we'll take in, it'll guru out here, and we can reboot. Let me go ahead and put everything back in order here, and I will see what could be causing this. It's just a typo on my end. Okay, sorry. I had to take care of something real quick, and I found the issue. So this was my fault. This was a wait instruction that I had placed in here in the task here when I was debugging something we had previously done in the video here, and I forgot to take it out. Because this wait was happening, it was basically sitting here at this point. We had created the port, but we weren't processing anything, so we were basically just... we were hitting a point where we were going to take and try to connect to a port that was there, but was not able to process messages and therefore crashing. So removing that and rebuilding basically gives us what we look for here. And now if we run ScoreTask, which I've already done here, oops, we have one other issue here. We have message ports that have leaked here. So we're going to take care of that in the next bit. So let's go ahead and reboot, and I will rerun this here so you can see the message actually making it to the port here. And I'll bring up the point that I just tried to make a moment ago after we run this program again so that it's more evident. Oh, silly little blips that I go through. I apologize, fellas. I try to be polished about this, and sometimes it doesn't work. But you'll see right here that we take and send our message here to our score task, which takes and shows our score display. The tasks run, the tasks stop, and that's the end of it here. Except there's a bit of an issue here. Right now, we've created a public message port, and we're sending stuff to it, but we didn't delete that message port. So that message port has now leaked into the system here. Well, how do we fix that? We fix that by basically sending a stop message when we want, before we actually delete the task, so that the task can delete the message port and get everything into a consistent state. Now, because this message port is still leaked here, we want to take and reboot the system to put ourselves back into a consistent state so we can make this change. We'll go ahead and do that. It really is worth noting one of the biggest differences between the Amiga operating system here and modern operating systems now, because we're not using a memory management unit, we don't have memory protection. So the things that we do here in the course of development, mistakes that we make or things that we don't implement, such as taking care of leaks and stuff that would normally cause things like segmentation faults further down the line, ultimately result in system crashes here on the Amiga, because again, there's no memory protection. But we can deal with this now. So all we really need to do, notice that we have just the same that we do right here, creating a message to take and send our reset here to go set the high score. This happens asynchronously. We do the same thing down here in our score task, except that we go ahead and quickly craft a message that will clean things up for us, the stop message that we've defined before. And that's easy enough to do. And since this is a single use thing we're not going to use again, we actually can quickly take and define this on the stack and just use it here for the duration of this stack frame. So we define a message of stop. And since this is on the stack, it's not one of these, but one of these. Message, and then node, ln type again. This is a node type, and there are different node types. For example, there are messages, there are semaphores, there are, there are all sorts of different things. And you can define your own node types if you want to. Again, same thing, set the type, set the length, and our command is ScoreCMD dot. And we put that message in over our task port. That's it. Because this is defined on the stack, we have to provide, and it's not a pointer, we have to take and provide the address for the message that we just created here on the stack. It does it, the message goes in. Since there's no reply port, we don't get any indication that this has happened, but we just go, okay, we assume that it's happened and the task is now waiting for us to be done. Even though the task is deleting itself, but this is kind of just insurance. It just happens to work. It's fine. Okay. Very good. So, oh, sorry. Not put, did I? All right, here. In fact, since we're doing it there, we'll just take and delay a little bit. Because the delete task is actually happening in there. So there we go. Boom. So there's our stop. We now have our reset message. We now have our set message. Now we need to take and amend our score task to update the scores whenever the adds happen. And then we'll do this and we'll implement our add command now. And our add command is actually going to happen in 2 sections. ScoreTask set, ScoreTask reset. And same thing. Same pattern as ScoreTask set. Except we're going to be doing basically a carry add algorithm here. This is very, very basic, and this is fully commented. If you actually look at this on GitHub, this will be fully commented here. I'm not going to be typing these in with comments. But we need a couple of variables that we know we want to deal with here. Since this is going to be running in a loop, we want a loop index. And we need a carry flag to know whether or not we need to add one if our previous digit has overflowed. Okay? And we're dealing with 7 digits here. We start at 7, and because we want this to go from, not from left to right, but from right to left, we take and do a decrementing loop. And that's canonically how you do a decrementing for loop in C. Just like that. So the first thing we really need to do, we need to grab the current digit as a character. And we, for both the source and the destination. Go ahead and put this over here so we can modify it and do stuff with it. The next thing we need to do is we need to take and create a code path to deal with whether or not the carry is set versus if it isn't. Okay. Then we'll start filling this in. So for carry here, we deal with this. We deal with the fact the way that we're going to be using this is, let's say we want to take and send a message here to take and add 100 points into player 1 here. Well, that's easy enough. S1, sure. Player 1, and say 100 points gets added in. So that's 3 digits, 4, 5, 6, 7. We need to take care of the case whether or not the source has blank digits and we want to ignore them. Okay? So for that, if CS is 0, then if the source digit is empty, we'll go ahead and set it to 0 here. And if the destination is empty, then we also set that to 0. Now, mind you, this is if the carry flag is set. This means that if a digit has overflowed, we need to turn these digits on and make them usable so that by the time we take and add in the carry, we'll have the correct digit show up. So this does the necessary house cleaning for that. Otherwise, if the carry isn't set and our source digit is blank for whatever reason, it's less than 0, we just continue. We ignore it. We just march forward. Okay, that's our first part, and that determines whether or not that's our carry logic. This gets set a bit further down in the loop. In any case, we take and convert the source and the destination digits, and we do this by subtracting the offset for the ASCII digit 0, which is hex 30. It's nice and easy. This is a quick way to take, and CS and CD are now, instead of hex 30, they'll be 0, or instead of hex 31, they'll be 01, and so on. Make it nice and convenient to deal with our adds and subtractions. Now, at this point, we can then take and add our source digit plus our carry to our destination. And go ahead and set the carry flag to 0 again, because something else may need to reset it. Clear the carry for the next round. However, if for some reason we overflowed past 9, just like we add or subtract in school here, just like we add in school, if we overflow over, we have to carry. So we go ahead and set the carry, and we subtract 10 from our digit here to get the number of digits that we overflowed over. Okay? At that point, our digit is done. We convert it back to ASCII, and we set the result into our destination buffer with our destination digit. That is the entirety of our add routine right there. So that will take and do all the math that's needed. But we still need to take, and if we reset the score or we add to the score, we need to update our score display. And the convenient place to do that is down here at the bottom of our task here. We can go ahead and just do that. We come down here at the bottom of our case loop here, of our switch statement, get past our switch statement, and we go ahead and place the score. Depending on our player number for our message, we do the following. Indentation, important for sanity. Okay, case 0 is high score. Case 1. P1. Case 2. Player 2. Break. And break. Okay? In which case, the score pointer that we defined all the way up here, which we're going to use to point to one of these 3 score variables down here, will then be used set to the appropriate score. So this means, okay, great, we place the score. Score is equal to, this is mostly just to keep the compiler happy there. You could actually just do And so score 1, whatever, and that will work too. But this really just kind of drives the point home. Score 1. So now score is set to that pointer. And we go ahead and set our Y position because we need to do a little bit of graphics work down here. Score 1 up Y, score up 2 up Y, etc. Okay. So now this is in place, and then we can turn right around. Go ahead and set a pin. Go ahead and set our pin to our score color here, because something else may have set it. We move the raster port to score X and whatever Y happens to be, because we set it up above there, and we update the text for that score. Just like that. Finally, one of the things that we do, we go ahead, I'm going to go ahead and implement ScoreTask high score, which will update the high score display if it needs to update for some reason or another. Finally, we're done with this message that we've just gotten right here. We were passed a pointer to it. It was allocated to us. We don't need to send a response back or anything. Therefore, we can just clean it up right here. That's fine. If you don't need to reply back or anything else, this is perfectly fine. You just need to make note that you've done that. So, we've got that. So I'll go ahead now finally, and we will implement score high score here. And this is kind of a silly little routine that needs a bit more debugging, but for the purposes of this demonstration, it works just fine. ScoreTask set, ScoreTask reset, ScoreTask add. ScoreTask high score, again, source and destination. And the whole purpose of this is literally to take and figure out if we need to update the high score display or not. And if so, well, then we update it. So I'm just gonna put this here without comment. We call ScoreTask set, which means I'm going to need to move this down a little bit. ScoreTask set. Then we move and go ahead and, yeah. And that's actually supposed to be the high score, high score X, whatever. So score high score Y, whatever. But this routine is just written really quickly in a pinch. If so, then we take and we break, and that's the end of that loop. Okay, so let's move this down a little bit. Move it past ScoreTask set just a moment. Put that there. And if everything goes okay, let's make absolutely sure that, all right, let's make sure while this is happening here, I'm going to go ahead and start a compile here, but while this is happening, I'm going to take and implement the messages for add so we can just watch them work. And set as well. We might as well go ahead and do this for the sake of completion. T-disk. Okay, ScoreTask. Now, I'll just wait. Okay, so there's a lot here to implement here, but hopefully you can see where this is all leading to, and hopefully I've been clear. If for something that I've done, it hasn't been clear, then please let me know in the comments. I really want to know. We'll go ahead and do the same thing for score command add here. We've got scores command set, we've got score command add. So let me go ahead and make sure this is here. Yeah. Then we do score task, add, message, score to, score, like that. Sorry. Else if message or else if message player known to add message score or 2. So now the calls to the score adds have been added. We have the logic down here at the bottom, which takes and updates the scores after those functions have been run. And we have high score that finally gets called at the tail end of things to update the high score, followed by freeing of the message that we've taken and processed because we're not replying back. We might want to actually reply back, so we may actually revisit this and add reply ports to the score task. I'm going to think on this some more. So, with that, the only thing left to do now is to take and fabricate messages to demonstrate the set and the add functions. So for that, we'll come right back down here to main. And we'll see that our reset, we'll come all the way down to our reset function here. Okay, there's our reset message. The score has now been reset. We see it work. And we'll start by basically taking and setting, we'll take and set player 2's score here. Do the same thing. Struct score message. And we will take an alloc same thing. Size of struct score message. And matter of fact, let me just take and do this as, let me just cut and paste this goofy thing right here, so I'm not typing so much. This becomes set2 message. Go to buy. Okay, fine, we've got that message. We can now take and do the same thing that we did here. Come down here, bam. So now this message becomes set instead of reset. And the player number becomes 2, because we want to change player 2's score. And the suddenly becomes, because we can do this because it's a string constant. But here we go. 1, 2, 3, 4, 5, 6, 7. Bam. Okay, great. There we go. Put message, passport, set to message. And that will allow us to take and set the score of player 2 to 100 points. And we'll then immediately come down here and create a loop which takes and adds 10 points to which adds 10 points to player 1's score each iteration. So we'll do this 240 times. And as part of this, we'll go ahead and just create the add message here. Why not? Much the same thing. Same idea here. We'll just take and copy and paste it. In fact, it might actually still be in my buffer. Nope. Okay, never mind. Pardon me. We'll put it here, and we'll just indent it over. This becomes our add message. Put message and put our add message. Put our add message, this score now becomes 10. That's what we want to do. Okay, great. That's all we really have to do. And we're going to add it to player 1's score. And this is going to be add. So that's it. We're going to be doing that. And after we do that, you know, we're going to put a tiny little delay in here so that we can just to mimic, you know, just to mimic a small delay here. We don't have to do this, but you can. It works just fine without it. So that's our add right there. Bam, 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 bam. Of course, recall earlier that even though we're allocating all these pointers to these messages right here, let me go ahead. Yes, sorry. My head is not on straight. Here we go. Let me put that in here so we can actually allocate our messages. Yeah, okay. Gonna take and do a little bit of indenting right there. So this becomes add message. If not add message, go to bye. Fine. Okay. Now, you may notice here that, yeah, we're dynamically allocating things, and we're basically going to buy to take and tear things down. And this can introduce a number of bugs, especially if you forget to not deallocate everything. Thankfully, though, Intuition actually does provide a structure to help us with that, which RJ called Remember. And going forward, at least in some videos in the future here, I will be using the Remember structure here to take and hold on to memory allocations that we do, so that if they fail, like they do like here, we can take and pass them in and deallocate them if they don't succeed, or, you know, deallocate anything that did allocate and ignore anything that didn't, so to speak. But I digress. So we've got this add message here. There it is. It's ready to go. We're now using it. And now, if I take and go build this, we should have the finished pieces of our ScoreTask demonstration here. Hopefully this all comes together and I didn't introduce any more typos. This video is coming up on 90 minutes long, especially due to just some bugs that I introduced that I had to hunt down while doing typos and stuff. But I hope you guys are enjoying the long forms of these videos. If you are, leave comments. If you aren't, leave comments. Leave comments so that I know that, so I know how you guys are reacting to this stuff. I'm hoping that it's at least useful and that I'm bringing something different to the table, trying to fill in the gaps of all this history, as it were. Oh boy. Okay. Unidentified, undefined, set to, okay, hold on, 494. Go here. Set to message, set one message. There isn't going to be a set one message, so I can pretty much get rid of that. I can get rid of that, so apps. There's one. There won't be a set one message, so I can get rid of that. So undefined identifier 507. So for some reason I doesn't get defined here. It looks like I might just need to add it. Let's see. Oh yes, I do. That's it. Let me fix that. We should be good to go. Any warnings of things that are dangling around? 495. There's no set one message, which that's fine. Let me look at 495 real quick, see if I can get rid of that particular message. Okay. Yeah. That'll go away once this actually gets built, so that's fine. Let's try this again. Now, one thing that you'll note, if you actually take a look at this particular example here in the on GitHub, you're going to find that it's not actually, that I actually built this on top of DrawMaze and not PowerPelletTask. So the PowerPelletTask is not in the example that's on GitHub. I decided at the last minute here to take and combine the two here so that you could see these tasks running simultaneously here, just to demonstrate that, yeah, you've got these tasks, they're running asynchronously, and they're just doing their little job, and doing a pretty darn good job of it. I felt that that probably would work better in context here. I might take and adapt this and move these changes into the ScoreTask in GitHub. Who knows? Regardless of which, the version that's on GitHub does have a fully commented score adding routine, so you can see what each line does individually. Okay, we've done our build. No warnings. I'll notice all our warnings are gone because now we're using all our little variables that we defined. Link and everything good. Thanks to that wonderful faster option, A-Link actually completes in an okay amount of time. B-Link is still faster, but B-Link came later. Now you'll see that if we run our ScoreTask, you see our blinking power pellets and you see our moving scores here. All this happening nice and neat in the context of our multitasking environment. Once it finishes at 2400 points, the delay happens and the program takes and exits. Hopefully I didn't do anything stupid. Maybe I did, maybe I didn't. Oh, there we go. Okay, so the program finishes, we're done, everything gets torn down, and thus ends this particular video. As I said, coming up, the next videos will actually focus on using the graphical element subsystem. So you get to see sprites moving around on the screen. So you get to see stuff like this. Let's go ahead and go into workspace. Let's go into PAC-MAN here. You can see what happens using the graphical element system here to move blitter objects around. You can see the blitter object is taking care of the backing store requirements, so it's moving cleanly across because this is being drawn on the playfield and updating and moving the playfield as needed, nice and smoothly. But also, with the combination of gels and the simple sprite system, now you have the ability to take and put all of the graphic elements on screen at the same time, with each of these graphic elements running in their own particular tasks. Doing great. And yes, I'm experimenting with priorities here, so anyway. But yeah, that's all single buffered, ironically. So that's all just kind of moving around. So this is what we have to look forward to. So now we're going to start digging into putting our animated objects on the screen and how these things actually come together. And as part of this process, we're going to be taking asides into using different parts of the gel system, such as the VSprite subsystem, such as the blitter object subsystem, and combining all these things together. So you'll get to see the finished results, but you'll also see the intermediate steps where we try different techniques and see the advantages and disadvantages of using each individual technique. We'll also take and do a bigger dive into the wavetable sound generator, so we can take and start doing sounds as well. So there's a lot more coming up, and I'm hoping you guys are really enjoying all of this. So until next time, guys, have fun.